Again, make sure those tests and quizzes get to where they belong. I think there was 2 tests and 1 quiz. The parallel lines quiz. One other quiz. They didn't pass them all out.
We did 3 and 1 else came out.
Let's wait until the end. We're gonna go on. So you don't have the quiz, maybe it's still laying there. All right. On the homework, follow along, open up your books. I'm going to go over a few of these problems just to make sure you understand them. We're going to go fairly quickly. On number 3. On number 3, they want us to name that. Please remember when you're naming a vector, the symbol for a vector is that. And we use 2 letters, the starting point and the ending point. So vector CD. Just like a ray or a line, except you got to use the vector symbol. Capital letters. When you're given the components of the vector, you're counting how much it goes left or right and how much it goes up or down. This one, looking in your book, how much did it go to the right? 7.
This is number 3.
Yep, how much did it go down?
3.
So that's a -3. So we would write it, that's how we name it, that's how we give the components. Next one, I already graphed this triangle. This vector tells us to do what to it?
2 over 6.
Right 6 and
Subtract
left, or I'm sorry, up or down?
9.
None. So we just go right 6. 1, 2, 3, 4, 5, 6. What's this point get labeled?
D prime.
Good. D prime. 1, 2, 3, 4, 5, 6. That point?
D prime.
1, 2, 3, 4, 5, 6. And that one? F prime. What should be true about the 2 triangles? They should be congruent. They should be the same. What's this one tell us to do to the triangle?
Go down to, or go back to
Left 2,
down 4.
down 4. Left 2, 1, 2, down 1, 2, 3, 4. What's that point going to be labeled?
D double prime.
We probably want to do a double prime since we're on the same graph, right? Back 2, down 1, 2, 3, 4. E double prime. Back 2, down 1, 2, 3, 4. F double prime. What should be true about all 3 of those triangles? They should all 3 look exactly the same. If they don't look the same, then you probably counted wrong somewhere. Go back and figure it out and fix it. Don't make this stuff harder than it is. So if you ended up with a triangle and it looked like this, and it doesn't look like that original one, go back and fix it. Figure out what you did wrong. You counted wrong somewhere. I have complete and total faith in all of you that if you count wrong once, you're probably not going to count wrong the second time. You're probably going to figure it out, right? Write as a vector. I think in the book, what's this point in the book? What's it labeled? M?
Yep.
And then this one's M prime?
Yep.
So which one's the original or the pre-image? The blue one, and then the red one is the image. So we want to write this as a vector. What did I do to go from this point to that point?
Well, up 1. All right. Right 3.
Right 3,
Up 1.
up 1. So as a vector it goes 3, comma, 1. Now if we're writing it as a rule, the rule looks like this. It's xy goes to, and then it's got the parentheses still. These both are going to mean the same thing, just written 2 different ways. What do we do to each x coordinate? We added 3, so it's just going to be x plus 3. What do we do to each y coordinate?
Add 1.
So y plus 1. This is in vector form, this is in rule form. They both mean exactly the same thing. Nothing different about it. Just 2 different ways to write it. When you were back in 5th grade, you wouldn't have written it either one of these 2 ways. Your teacher probably would have written it something like this. right 3, and up 1. All three of those mean exactly the same thing. Younger kids, you guys, because they expect that you can understand a little more now. Next one. What's the image of 2, 6? If this is our rule, this is what we're doing to that point, 2, 6. We don't even have to graph it. All we have to do is look at what we're doing to it. What's this telling us that we're doing to each x coordinate?
Now you're going to the left 8.
So if I take this 2 and stick it in there for x, what's that leave me with? -6. 2 minus 8 is -6. If I stick the 6 in there for y, what's that leave me with? So if we were to do this rule, this slide on that point, we would end up at the point -610. The EOC test, these are the kind of problems they like. They don't like this one because that's too easy. They want to see that you know and can use stuff and can use it however it's given to you.
Do we have to take that?
Yeah. If this is the pre-image, they're telling us this right here is the pre-image, so that's what we end up at. We're trying to figure out where we started at. Can we just plug in -3 there and do -3 minus 8 and see where we started? No, it's not going to work because we're starting at the end and going back to the beginning. So what are we going to have to do here? Do the opposite. You do the inverse. Just like when you're doing algebra and you're trying to get x by itself, you do the inverse. If you're subtracting 8, you add 8. If you're adding 8, then you subtract 8. So instead of -3 minus 8, it's going to be -3 plus 8. What's that give you? So we started at x being 5. Instead of y plus 4, it's going to be y minus 4. So -10 minus 4, what's that? What is that?
-14.
-14, good. So that's the point we started at. That's our that's the pre-image, that's the image. I think I said that backwards a second. Pre-image is where you start, image is where you end up. Next one, we take those 3 points. We could graph this. I don't like graphing anything. If I don't have to graph it, I don't. Right? If we have these 2 rules, all we're going to do to it is exactly what the rule says. I'm just going to do one of these. P prime. What's this rule tell us to do to each x coordinate?
Right 4.
Add 4 to it, right? So what's -2 plus 4?
4. 2.
What's it tell us to do to the y coordinate? Add 6. So what's 3 plus 6?
9.
So P prime is going to end up at 2, 9. Then we do Q prime. Somebody tell me what Q prime is going to be.
5, 8,
5, 8. How about R prime?
7, 5.
7 what? 5. That's where the new triangle is going to be. If that confuses, if Kelsey back here is confused by me just finding the points, is there anything wrong with graphing it and then doing it? No, go right ahead. All right? I'm just trying to show you that not always do you have to graph all of them. All right? If it helps you, if you're more of a visual learner, then do it that way. Graph it and go over 4 to the right and up 6 and put your points. But we could also do it this way. Compositions. Anybody remember what's a composition? What's it mean when you're doing a composition? Is that like writing an English paper? Not math, right? Composition means you're doing 2 or more movements. You're doing 2 or more things to the shape. So I already have the shape down here. The first thing we're going to do, what's this telling us to do to the shape? Left 6, and then stay there. We don't do anything else to it.
Isn't it, if you're only doing like one transition, then it's not a composition?
Right. If it's
But
just
if
one
you're
thing,
doing
if you're
two
doing
transitions,
two things to it, or 3 things, or 4 things, and this is more, again, the EOC test. They won't put one thing on there where you just gotta slide something over 5 units. They figure a 5th grader can do that, alright? They're gonna put something over there where they're gonna say slide it 5 units to the right and then rotate it 90 degrees counterclockwise. So they're gonna want you to do a composition, 2 things. So this one tells us go left 6, 1, 2, 3, 4, 5, 6. Up or down 0, because it was just Y. What's that point gonna be labeled? X prime. 1, 2, 3, 4, 5, 6. That's Z prime. 1, 2, 3, 4, 5, 6. That's Y prime. What should be true about the 2 triangles when I'm done drawing that second one? They should look the same, even though mine doesn't look very good. Then they want us to do this translation to it. What's it telling us to do? Right 2, up 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. What's that point going to be labeled?
X double prime.
X double prime. 1, 2, 1, 2, 3, 4, 5, 6, 7. Z double prime. 1, 2, 1, 2, 3, 4, 5, 6, 7. Y double prime. Again, what should be true about all 3 of those triangles? They should all be congruent. Alright? So if you came up with a triangle, one of your triangles looked like this. When you moved it, you look at it and, well, that don't look the same. That probably means you counted wrong on one of the points. Just fix it. Describe the composition. They do a lot of this on the EOC test. Lots of stuff with where they want you to actually tell what happened to the shape, not them telling you what to do to the shape. Which of these shapes, blue, green, or red, is the original shape? That's the original, so that's 1. Which one's the second shape?
Red. Green.
What did I do? And let's just do a vector. What did I do to go from blue to red?
We're up, or what?
X plus 1.
5 to the right.
5 to the right,
5, up 1.
up 1. So that would be our vector, right? Now a lot of you are wanting to write it this way. X plus 5, Y plus 1. Is there anything wrong with writing it that way?
No.
No, I was just being lazy, writing it as a vector because it's shorter. Okay? So that's your first movement. Your second movement. What did we do to go from red to green? We'll write a vector again.
You went down.
Negative 2. Is that right?
Go down to the red.
You went -5.
Negative 5.
Yep.
So we went left 5,
Oh, I see what I did.
left 5,
You went down.
down what?
We're down 7.
Down 7,
I think, but
5.
I think so. Is it 5?
So what's that tell me? Do I just put 5?
Negative.
Negative 5. That's our first movement, that's our second movement. Make sure X, then Y. Don't get it confused with slope, where it goes up or down first, then left or right. A lot of you are turning that around. The second page. Graphing, and again, we talked about this last time, in the y-axis. If you say over the y-axis, I won't throw a big fit about it. But mathematically, the correct word to use is in the y-axis. I'm going to graph this point just real quick, or these 3 points. 5, 3, that's J. 1. If I count wrong or something, somebody please tell me. That's K. Negative 3. And 4, 1, 2, 3, 4. That's L. So our triangle looks something like that. We want that triangle to be reflected in the y-axis. So if I graph it, the easiest thing to do is just what? Just count how many spaces. All right? You gotta go. Make sure you guys stop back and get the assignment stuff. It's on page 194. Get it off somebody. So we do this, all we do, how far is the point L from the y-axis? 3, so we go, if it's on the left 3, we go to the right 3. Excuse the stupid lines. J is 1, 2, 3, 4, 5, so it goes over here 1, 2, 3, 4, 5. Again, if I count wrong, somebody please tell me. That's J prime. K is 1 space on the right, so it goes over 1 space to the left. Does that shape look the same as the original one?
Sort of, yeah. Yes, it does. It just-
When you start doing rotations, reflections, if you don't graph the stuff or use the rules, you will end up messing up. All right? Because I'll guarantee if I put this on the test, a whole bunch of people would just sort of flip it, but L would still be higher than J when they flipped it around. So you got to make sure, or I'm backwards, J would be higher than L, is what I was trying to say. The harder ones, on these harder ones, I'm going to erase this real quick. If we do this one, terrible X and Y axes. 1, -1, that's J. K is 3, 0. On these next 2 or 3 that I do, you got to watch closely because otherwise you will mess these up. 0, these are the new things. You've done the other stuff, these you might not have done. 0, -4. That's L. Every single time I draw these triangles, I put my letters in the way. So that's our original triangle. We want to reflect it in x equals 2. Does anybody remember what kind of line is x equals 2? The vertical line. You've got to know x equals some number is a vertical line, y equals some number is a horizontal line. So x equals 2. We go to where x is 2, 1, 2, and we draw in a vertical line. That's the line we're reflecting across this time. If you draw this and you draw that line in, you can do the same thing we did on the last one and just count. K is 1 space to the right, so K prime is going to be 1 space to the left. J is 1 space to the left, so J prime is going to be 1 space to the right. L is 2 spaces to the left, so L prime is going to be 2 spaces to the right. We connect those. Horrible. Color it in so it doesn't look quite so bad. Do the 2 triangles look the same? That's the key to that, is you got to know that's a vertical line. Y equals some number is a horizontal line. We're doing it over y equals x. Y equals x is this line. It helps you do this. Plus 0. Now it's in that slope-intercept form. What's the y-intercept this time? 0. So we're right there. What's our slope? 1. So that tells us go up 1, right 1. Up 1, right 1. Up 1, right 1. Or we could go down 1, left 1. Y equals x is the line that splits the coordinate system in half, going up from left to right. Y equals -x, which is on the next slide, the one that splits it in half going the other direction. Down left to right. So we do that. This is the one you're going to mess up if you don't use the rule. What was the rule? Somebody help me out and look at your notes from last time. What was the rule that we said about this? We had a rule that said xy goes to what? Yx. Is that what it is? That don't sound right to me. YX? I just want somebody else to look it up over here. So we switch it to YX. Now, I think on your notes it said, no, that's today's note. I won't even say that. So all we're gonna do is change these points. You got to do it this way though. We need to find A, B, C. Find those 3 points, then switch them to A prime, B prime, C prime. And I know I'm gonna have people like Dawson back here who says, I don't need to do that. I could just look at it and tell. You're gonna mess it up. All right? This one here is not too bad. The one on the next slide, a whole lot worse. What's the coordinates for A?
Negative,
6, -3.
no,
6, -3. Everybody agree with Harry?
Yes.
B,
1, -2.
1, -2. C.
4, 1.
4, 1.
So now we have those points. What's this rule tell us to do to those points? To switch them. So A is going to be,
-3, 6.
what's B going to be?
-2, 1.
And C?
1, 4.
Got to do this rule before you start to graph it. All right? Do the rule, see what the new points are going to be, then worry about graphing it. So -3, 6, 2, 4, 6. That's A prime. -2, 1. That's B prime. 1, 4, 1. 1, 2, 3, 4. That's C prime. We connect them, put the names in the way every single time.
Would it work to count over on the X and then go up on the Y the same amount?
And that's fine on this one, because what's true about the distance C is from there and the distance B is from there. It looks like these two are parallel to each other. So that works out well on this one. On some of the others, maybe not so well. All right? So you got to be careful trying to do that. I mean, there's a way, yes, you can do that. I would swear it's going to be easier doing it this way, because this works all the time. Question, Dawson?
so what if the graph goes up by 2s or 3s, like a different number than 1?
If that happened, you would just have to remember when you're graphing these points, because if you come over here and you figure it out and it's going up by 2s, and this point's 6, -3 or whatever it is, that means you knew it was going up by 2s already, so you wrote this down correctly. When you switch it here, it's still going to be the same thing. All that's going to change is when you get over here and you start counting, you got to remember that it goes by 2s. So that shouldn't affect any of your work. Next one. So it's on this one, Ginger. This one's going to be a little different. If we look at this, y equals -x. Somebody help me out. What's the rule for y equals -x? xy goes to what?
-y, -x.
-y, -x. Everybody agree with Harry on that? Yeah? So let's find A, coordinates of A, coordinates of B, coordinates of C. What's point A this time? 1, 2. B?
4, 2.
C? 3, -2. All right? Now this line, y equals -x, goes down through here. It's right up through there. It's right down through there. Splits the graph in half, going down left to right. A prime, B prime, C prime. We switch it around, change the sign of both of them, right? So -2, -1, -2, -4, +2, -3. Now let's graph these. -2, -1. It's A prime. -2, -4. Oops, too far. That's B prime. 2, -3. C prime.
I thought it does work.
Does it? Didn't do it that way, but I think the farther you're getting from the line and stuff, it's gonna mess you up. Do it, if you can figure out how to do it that way, as long as you know how to do it, that's all I care about. Alright? So you gotta be careful when you're doing this. A lot of people, I guarantee you, when I put a problem like this on the test, what I'm gonna get is the triangle's gonna end up somewhere like in there. Because somebody just like flipped it over that way. That's what I get all the time. So you gotta use the rules. The stuff that we do today is gonna have rules also. Gotta use them. How many lines of symmetry on this picture? Where's it at?
Straight down the middle.
Here?
Yeah.
How about on this one?
Two down there or four down
Is that all of them?
Yeah.
You could do the corner.
Through these corners?
No.
That one and this one?
Yeah. Same the other way.
Same the other way? You sure? That really works?
No, last time we had that, you said no, because then it don't line up.
And I said it didn't work
It's ready.
if we went this corner to this corner, right? Because if we go that corner to that corner, do they line up?
Nope.
They gotta match up. To be a line of symmetry, it's gotta match up. Now you guys said this corner to this corner. Will that work?
Yeah.
Yeah, that does work. So how many lines of symmetry there?
Last time you said it didn't.
The last time I said this didn't work.
Well, you didn't the other way.
You didn't tell me that.
Well,
How many on this one?
None.
None. Even if I draw it this way, that's not line of symmetry?
Nope.
This triangle's the same as that triangle.
Yeah, but
It's not gonna match up. Go ahead, just write down rotations. As a matter of fact, I'm gonna turn this slide. So remember, Jenna, can you remember rotations? Rotations, because it's gonna be your job to tell whoever can't remember here in a minute. And go ahead and start copying this down. These are your notes for today. What were you supposed to write, Jenna? Maybe you forgot already.
rotation.
Easy say it. Tell him he could help out instead of critiquing. He could have just helped and said it. Your job.
I was writing something else.
I wish I had any handwriting, but what's the abbreviation for rotation? Can I just do like a circle with an arrow?
Whose notes are those, Peyton?
Mine.
You can understand what you're writing.
That's too confusing. I don't even remember my own name sometimes.
My next statement was going to be, but when it comes time that you need those notes, don't call me over and say, what was this symbol? When you made up the symbol.
I should make a symbol key. And then I won't have to remember it. Yeah.
That you just, the last one.
I'm just gonna give it back.
Huh?
I'm just gonna give it back.
No, I mean, the last number as far as writing your notes, the notes will, time you're doing notes, y'all are doing with pens because that way they stay around a long time. Pencil will fade away.
Is this gonna take
Right.
like
Usually lefties have trouble with that.
Yeah, I actually have to write off the paper. I can't put my hand on the paper. Like, it's really hard to
When you're doing rotations, you have to have three things for any rotation. You have to have a center of the rotation, angle of rotation, and a direction. So they have to tell you those things. Normally, our center, the one that we'll deal with the most, 0, 0. So if we're on a graph, the center of rotation will normally be 0, 0. Not always, but most of the time. Angle of rotation. When you've done rotations in the past, what were the normal angles that you probably rotated something?
90 degrees.
That's direction. 90 degrees, 180 degrees, 360. There's one other one. And everybody always misses it. You said it backwards.
180.
You see, you mixed up the numbers.
270.
270 and 360. Everybody always forgets the 270 because you usually don't do a whole lot with that. And the reason we don't do a whole lot with it, if I'm standing here and I want to turn, let me turn this way so that I'm the same way as you guys are. I want to turn 90 degrees clockwise. Clockwise, going around the clock this way, so I want to turn 90 degrees this way. That's a 90 degrees clockwise turn. If I'm standing here and I want to turn counterclockwise, now I've turned how much? 270 counterclockwise. So 90 degrees clockwise and 270 counterclockwise, same thing, or vice versa. So that's why you didn't use 270 very much. It's just going the opposite direction.
Is there going to be different
So-
angles that we measure with, like 30 degrees?
Yeah, we're going to do some of that here in a minute. The direction, clockwise or counterclockwise, there's a clock up there. Just look at it. You need to, and you're sitting there doing a problem. Do that so you know which way you're turning. I got to do this every time I'm going to do something up here on the board. If I want to go counterclockwise, very first thing I do, I draw an arrow pointing that direction so I know, hey, that's counterclockwise. So I make sure I'm turning the shape correctly. If I'm going clockwise, I draw an arrow going the other direction. Just to make sure. You might do that on your paper each time to make sure you're going the right direction. All right, what I need you to do, I need you to grab a worksheet, a ruler, and a protractor from up there on the table. What you're going to do on this, I sort of wish that I hadn't put this on graph paper, because on graph paper it sort of gives you the wrong idea. Because there's some of these you're going to have to do freehand. Now, when we do something like this on a test freehand, I'm not going to expect that your picture is going to be perfect. All right? Does everybody understand that? I'm going to be looking for three things. Number one, if I rotate this 90 degrees about point P, what should be true about that shape when I'm done?
It's the same.
It should be the same. So your shape should look the same. We're not making it bigger, smaller, anything. Should look the same. Second thing I'm going to be looking for. Did you go the correct direction? If I said rotate it 90 degrees counterclockwise, which direction is my shape going to be moving?
Left.
It's going to be moving up like this, right?
Up.
All right, so that's the second thing. The third thing, did you go the right amount? If we're going 90 degrees and your shape ends up over here, did you go the right amount?
No.
You probably went too far, right? So those are the three things I'm going to be looking for when we do this, when we have these problems on the test. Now I'm going to show you how to do this. Sort of treat it like these aren't here.
What is number 1 up there?
Make sure it looks the same. The shape should look exactly the same as it did to start with. So when I take this shape, Ginger, if I take this shape and I rotate it, it still looks the same. I didn't make it bigger or smaller or anything else. When we do this, and this is going to be important for the next section too, what we're sort of going to do here, and it's going to be hard to look at, but this is how I want you to do it on your paper. You're going to take your ruler and you're going to connect A to P. So take your ruler and connect A to P. Notice I wasn't lying to you, Jason. I had to draw that up there, otherwise I'll forget and I'll mess up the whole problem. Once you connect A to P, now all you're going to do is you're going to take your protractor and we're going to line up the hole with P, that line you just drew with the 0 along the bottom. How many degrees do we want to turn it? So I'm going to go up here to 90, and I'm going to draw another line that goes up this way. What kind of angle is this angle right here? 90 degrees. It's a right angle. So it's like we're taking, if I'm standing on A right here, and I take a bouncy ball, and I throw it at point P, and I know it's going to bounce off at a 90-degree angle. It's going to go that direction. That's what we're looking at. A prime is going to end up somewhere on that line. All right? When we turn this, when we rotate this 90 degrees counterclockwise, A prime is going to end up somewhere on there. Now the way we got to figure out where it is on there, I'm going to try not to use a ruler because I don't really want to use a ruler. When you grab the ruler up there, you can use the ruler, but don't actually measure it. I'm not looking at it to be that precise. This is the way I'm going to measure mine, if I could ever get these to stick together. A is about that far from P. Does everybody see that? It's about that far. You could take your fingers and maybe do this on your paper. A is about that far from P, so guess what should happen with A prime?
It should be that far.
That should be that far from P. So A prime is going to end up somewhere right about in there. You can use your ruler or whatever to just sort of measure up it. But I'm not saying, look at it and go, oh, it's 1 inch and 5/8. How'd you mess up?
Like I just rotated the right angle 90 degrees, like B and C. I didn't rotate A.
Grabbing the...
We were willing to.
Yeah, I might let you have one just so you can draw straight stuff. I don't want you measuring it so much. All right? I don't want you going, oh, that's 2 5/16 inches. I don't care about that. Notice I'm using my fingers up here. So it's about that far, about that far.
You can take the points off.
No, probably not. I'm not going to take points off, Jacob, for being more precise than I want you to be today. Now we're going to do the same thing, but we're going to do it with B. So connect B to point P. What kind of angle are we going to come off of P at? 90 degrees for this problem. If I come up here, it's 90 degrees about there. So it's going to go somewhere about like that. Just to make Jacob happy, I'll use my ruler this time. But look, Jacob. Oops. I'm still not measuring. I'm just doing this. How far is B from P? About that far. So how far should B prime be from P? About that far. So right about there. Now hopefully yours, since you have a ruler and stuff and you're using it, making your lines straight, and I'm not, I'm just drawing them. Yours might look a little better than mine. Guess what you're going to do with C?
Same thing.
Same thing.
Whoa, look at it.
Connect C to P. Come off of that one. Make sure you're using, I know this gets confusing because you have so many lines on there. So you might make your lines maybe not completely dark or something. All right. Go up through here somewhere. Then you measure how far C is from P. C prime should be that same distance. those 3 points, guess what I'm gonna do with those 3 points? Connect. Hold on, give me a different color. So I connect them, and I can see the disbelief in all of your eyes. So your shape's not gonna look anything like the original shape looked. Mackenzie back there didn't believe in me at all. Does that triangle look like the original triangle?
Yeah.
Yeah.
I'm just confused, like, on the angle parts.
Mine is.
Like,
Mine don't.
the lines that you have to make on.
Just me.
So all you're doing is, if I take point C here, Dawson, think about it this way. You're standing at point C and you throw a bouncy ball. It's going to come over here and hit P. And when it hits P, it's going to bounce off of P. We want it to bounce off at 90 degrees. So I took this, that's got to go on P.
Okay.
You line that up, and what's our angle that we want? 90 degrees. So it's got to come up there like that somehow. Does that make sense?
Yeah, I get it.
Does that look about the same?
No, mine looks like. Mine looks like a shape. Mine is out.
Why doesn't it look the same way? Yeah, see, you're trying to be precise at this one.
No, I was actually doing the finger thing. No. And that didn't work.
Which question, Peyton?
With this one for the pre-mint, the B and the C are in a line, so could you also do that? If there's a graph under it?
You got to be careful because maybe, but when you're turning it, just because B and C were vertical here, does that mean they're going to be horizontal when you turn it up here? Not necessarily. Right, depends on the degree of the angle that you're turning.
So if it's 90 degrees.
If it was 90, so mine, you're probably right. My B and C, they probably should be more level.
Yeah.
Two Y's. That's not wide enough. Again, if you're looking at your paper, you could grade yourself right now. Does your shape look like the original one? If it does, that's a point. Did you turn it this direction?
Yes.
That's another point. So you turned it the correct direction. Did you turn it to where it's about in this area where it was 90 degrees?
Yes.
So that'd be 3 points.
Yay. Oh, 3 points.
Now, if your shape doesn't look like the original, it got a whole lot smaller or something, then maybe you only get 2 of the 3 points.
Where's that longer?
Huh?
Where's that longer?
No, it didn't. Where's it longer? From what to what? A to B?
prime to B prime.
A to B? Alright. 13 and a half inches. You see that?
No.
13 and a half, 13 and a quarter, somewhere around there. Oh my goodness, what's that say? 13 and a half.
Yeah, but from B to C is different.
About 7 inches. Oh, I'm off a quarter of an inch.
Oh, she knew it.
Longer, short,
Looks like it's way
A to C is also long.
All
Then A to C is different.
I'm not doing it anymore.
But it seriously looks different.
Look at the next one.
We're doing it ourselves.
That's why you
You
don't.
want to try it yourselves before I do it? No. Yes. Go ahead, you can try it. I'll give you just a couple minutes. If you don't want to try it, just wait till I get up here to do it. Sorry?
Yeah, I was naming.
Oh, I didn't name A, B, and C? Yeah, I put A, B, and C on there, sorry. Well, me being lazy. Figured, hey, you could remember A, B, and C. Yep, that was all right.
There's something to remember.
Right there, one.
Oh, rotation.
Don't come Jacob.
I had to do an entire clock just to remember.
Just do a circle with every other one. Well, the other direction.
Clockwise is going that way.
Oh, you want us to do this by ourselves?
You can try it real quick. Someone said they wanted to try it on there.
Yeah.
I ain't trying
I did mess up. It looked like this big. It was a square, so. I don't know how I got a square. Is it possible to get a square in this?
Get what?
A square?
What, and do instead of starting with a triangle?
No, I mean,
Or-
if you have a triangle and you want to make a square, is it possible?
Probably not.
Oh, okay. Well, then I did it wrong.
So if you end up with 4 points instead of 3 points, Mackenzie, there's something not right.
Good job.
Thanks.
Is the erase mark still there? I see it.
No.
No, it's not.
It's okay, I only saw 2 points.
Doesn't look anything like the other. Watch, I'm gonna try to do this one. I'm gonna go over. I'm gonna try to do this one freehand, without using the stuff, just measuring, see how close I can get. First thing I always do, number one, it probably hurts you if we're doing a 60-degree angle. If I go back to the other one, let's jump back to the previous one. See, erase all this crap. If we erase all this, if you are doing something like this and you're on and you can get a piece of graph paper and you know you're doing 90 degrees, could we make that point P right there? What coordinates could we make it?
0, 0.
And then these rules that we're going to learn here in a little while, if you're doing 90 degrees, something that has a rule, we could just use the rules.
But you could also make it 3, 5.
Right, but we don't want to because that makes it harder. So if we're allowed to make it whatever we want, we'd like to make it 0, 0. So if you get one like this and it's on a graph, make point P 0, 0 and run it that way. But the bad thing is we only have rules for 90, 180, 270, and 360. No, that could be for 90, 180, 270, or 360.
Only for the.
Only for those, because we don't have rules for all the other numbers. All right, you don't want me to have you write down rules for 1 degree, 2 degrees, 3 degrees, 4, all the way up to 360. That's too many rules. You'd never be able to remember them all or use them all anyway. So we could do that if that was the case, if it's 90 degrees. On this next one, it's 60 degrees. That won't work. So I'm going to try to do this freehand. I know I'm going that way. The first thing I usually do after I draw my arrow showing me which direction, I draw a right angle out here, because then I base everything off of that. If I want to go 60 degrees, 60 degrees is about 2/3 of a right angle, so it's about that much maybe. And I leave that out there just so I remember, hey, that's about 60 degrees. You got a protractor there, so you could get it more precise, make it more precise. I'm not going to. I'm going to look at that and say, okay, that's about 60 degrees. I'm going to take A, I'm going to bounce it off P. We want it to go that direction, about 60 degrees. I'm going to say 60 degrees is about that. This is going to drive Jacob nuts. That's my measurement from P to A. That's going to be my measurement from P to A prime. I don't know why I just did that. I wanted to use this.
Make sure you use
That's A prime. Yeah, use the same, however far A is from P, that's how far A prime's got to be from P. Now I'm going to erase this. That's my A prime right there. I'm just going to leave the points up here while I'm doing it. Do the same thing for B. Connect B to P. Wow, that's horrible. B to P, it's got to go up this way 60 degrees. Might be about a 60-degree angle. Measure.
Is this what our homework's gonna be about?
Yeah, some of it.
I got it right.
That kind of fun.
B prime should be somewhere about in there. Now, if I'm way off on this, then that means on the next test, I can not count you guys way off just because I can't do it either, right?
Yeah.
C, we connect C to P, it goes right there, 60-degree angle. Somewhere about in there. Measure. C prime is going to be somewhere about in there. Erase this. What am I going to do with those 3 points?
Connect them. Connect the dots. That's a fun game.
Does my shape look about the same as the original? Yeah, it does. Might be just a tad bit smaller because my lines are bowed in. So it looks about the same. Did I turn it? Which way did it turn? Turned to the right, didn't it? Did I turn it the correct way? Yeah. Did I turn it what looks like about 60 degrees? Probably so. 60-degree turn. Wouldn't be a whole lot of a turn when you're that close. All right? Which question? Let's see. So you took your B out too far. See how far B is from P here? About that far. So when it bounces up here, B should be somewhere like right here. I don't know why. Maybe, if you did though, switch your letters around.
Then I, because like, I.
So you switched your A and C off.
Drew on the, that one, how it
Just your A, just here. Should have been out here somewhere a little bit. You just gotta hit it all.
You want to believe me if I can just like that?
Shit.
You want to believe me if I can just like bark
It looks like you went, see this angle right here from B to B? That looks like it's about 110 degrees. So your B should be way over in here somewhere. So you might have used 120. You might have you went 120 instead of 60. Use it. You gotta look at the numbers. Remember, acute angle, 60 degrees acute angle. So you gotta use the one, whichever number goes with the acute. That's why the protractors are see-through, because if you turn them around, no matter how you put them, you're still, okay, if I want to come from here up, then I'm using the 60, not the 120.
Demonstration. Oh. Demonstration. Put yourself in the face on accident.
Good. Don't move my ruler around. I think we had that conversation when we dealt with these the first
Yeah, it was
time.
on the first day of school. I still remember.
I forgot about that.
I'm surprised I remember
I
that.
do them like,
Go ahead and copy this down. These are the rules for graphing something clockwise or counterclockwise.
Can't see, so.
4 rules.
I got you. Okay.
Now I'm blank.
Now you'll notice here, as you're writing this down, this table, on the next test, I think I told you this last time, you're going to be allowed 1 sheet of paper. What's going to be a good thing to have on that sheet of paper on that next test?
Absolutely everything.
These rules. So make sure you write them down. Make sure you write them down correctly. On these, I probably was lazy and I just copied something off the computer somewhere because they use A and B. If you don't like A and B, you could change A into what? X. B into Y. If that makes more sense to you, then do it that way. Change all the A's to X's, all the B's to Y's.
I got a question.
Yeah.
So if you write everything down on one piece of paper, can you like everything for?
Nah, all you're going to be allowed this. Yeah, if you could get everything on 1 sheet of paper, but don't even you won't be able to read your Dawson. You won't if you spread your stuff out, you won't be able to read your writing anyway. If you
You're
make
right.
it that small, you sure won't be able to read it, and it won't do you any good anyway.
Yeah, you're right. You and me.
As you're writing it down, anybody notice anything about 90 degrees clockwise? That rule.
Looks pretty good.
See it anywhere else?
Spell now again.
Yeah.
270 is just.
270 clockwise.
270 counterclockwise, right?
Oh, yes. Okay.
90 degrees clockwise, 270 counterclockwise. Same rule.
It's just.
Oh,
Just-
and the same thing with counterclockwise and clockwise.
For the other direction, right? For 90 and 270. What do you notice about 180?
It's the same thing with 360.
Except it's both negatives and then 360 is both positive.
Look at 180. What do you notice about it?
Oh, it's the same thing, counter and clockwise.
Same way, same thing clockwise or counterclockwise. Because if I'm standing here looking at you and I turn 180 degrees counterclockwise, if I'm standing here looking at you and I turn 180 degrees counterclockwise, I end up in the same spot. All right? So 180 is the same either direction. What do you notice about 360?
They're both positives.
Maybe. A doesn't have to be positive, B doesn't have to be positive.
Very same.
It's the same. So if I'm standing here and I turn 360, what ends up with, I turn 360 degrees, where do I end up at?
Same place.
Same place I started. So that rule, that's the one that everybody likes a whole bunch. Guaranteed there won't be any of those on your test.
What about the big test?
No. I'm never putting anything 360, that's too easy.
No, I meant like the state test.
Oh. I sort of doubt it unless somebody's feeling funny that day when they made up that problem. Because if they ask you to rotate this pentagon 360 degrees counterclockwise,
Same, isn't
and it ends up being the exact same place, it's just so that they could laugh at you if you mess it up.
Well, it feels like they like to do that sometimes.
Hell, the computer grades it all now, so they probably wouldn't get to laugh, so it wouldn't be any fun for them. Now, if it was on my test, maybe I would have a good laugh, but since I just told you, I'm not putting anything that easy on there.
Or they probably put it on there as a curveball.
You should
probably
put it
don't
on
know.
there as a bonus question.
Bonus question.
Just
That's a
360.
great bonus question, please. I think
Because
the one kid that gets.
because
one.
most people don't like. feel
Don't
like
even
they
read the bonus.
Yeah.
Yeah, that's me.
I've done that on a couple of, as a matter of fact, I think the first test, there was a bonus on there that was a it was like the easiest question on the whole test. And a lot of people didn't bother to do it.
I did it.
So you got all these rules. You've got to, as you're turning this stuff, you've got to write down the coordinates of the original shape. Then use the rule to write down A prime, B prime, C prime, or whatever the letters are. All right? Use the rules. I don't even care so much about the graph most of the time. Use the rules and write down what you come up with. What's your question, Ginger?
So the negative signs, does that mean just the opposite?
It's the opposite. So don't think that this is a negative. Because if A started out as -3, what would this coordinate be? positive 3. It's the opposite. That means the opposite of whatever A was. Opposite of whatever B was. Notice on these, for 90 degrees clockwise, what'd you do to the point?
Inverted.
Oh, yeah.
Inverted them, flipped them around, and changed the sign of the second one. All right, the new second one, right?
Yeah.
Make sure you don't confuse yourself with that. Look at it and make sure you do it. So if I gave you a point, 2, -6. Let's just take that point. Let's do it 90 degrees clockwise. What would it be 90 degrees clockwise?
Six, -2. Oh, wait. we're doing
-6,
counterclockwise.
-2.
Okay.
Counterclockwise, what would it be?
Negative, 6, -2.
6,
Negative
2.
What?
Because on counterclockwise, you don't what?
Oh, counter.
You don't change that sign. What would it be if we went 180 degrees clockwise? Going back to the original.
6, -2.
Everybody agree with that?
No.
Should.
6, -2.
2 negative.
Look. We're doing-
180, it stays in the same order, but what do you do to both the signs?
-6, -2.
So same order. So what's it going to come up to be?
Negative.
-2,
-2, 6.
Yeah.
Got to be careful. You see how easy it is to mess it up, right? You got to use the rules, but you got to be careful when you're doing them. If we were doing this point, what's the coordinates on A right here?
-2, 2.
2, -2.
Yeah.
What's the coordinates of B?
I can't even see it, so.
10,
Jason's
-.
taking
1, 2, 3, 4, 5, 6, 7,
I was just
8, -5. Don't make me start handing out detentions. So we got those 2 points. We wanted to go 90 degrees clockwise. What'd the rule for 90 degrees clockwise say to do?
Flip it and make this new second one negative.
So what's new A, or what's A prime going to end up being?
Negative 5, negative
A prime.
8. Negative 5, negative.
A prime.
What? Oh, okay.
-2, -2. What's B prime going to be?
-5,
-5, -8. And could we graph that and find it? Yeah. What would A prime be for 360?
Right there.
Same place, right? I'm gonna do all this. Write this down real quick. Rotational symmetry. We only got like 3 minutes. Rotational symmetry. All rotational symmetry is, I'm going to explain this while you're writing it down. If I take this picture and I stick something, a pin or something in it, I stick a pin in it so that right in the center where it can't move. Rotational symmetry is rotating it around that center point. And when you're finding order of rotational symmetry, what you're doing is figuring out how many times it looks exactly the same as you turn it around one whole turn, or 360 degrees. Don't make rotational symmetry very hard. If I took this shape and the X is on top and I stuck something right through the middle there, tell me to stop when it looks the same as it does right now. That's 1. That's 2. That's 3. That's 4. So the order of rotational symmetry for this shape is 4. That's all it is. Look at this shape here. How many times, if we spin it one whole turn, how many times would it look exactly the same?
What is that word that's under the?
4. So order of rotational symmetry is 4. Under what? Turn, when turned. Now, when we do turn this, the book's going to want you to do this. When you turn this, how many degrees do you turn it when it first looks exactly the same? How many degrees did I turn this when it first looked the same? 90. So they're going to want those numbers. 90 degrees. When did it look the same again? At what turn? 180. Then at what turn did it look the same again? 270. And where did it look the same again? 360. Now the book, this book, they don't want you to go past 180. But if you don't do that, then you got to remember, does it look the same now as when I start? So instead of 360 degrees, that would be at 0 degrees. I would probably accept all those answers because they just want you to go halfway.
I got a question.
Yeah.
What if you have a shape that's like the angles or the lines are different measurements?
Yeah, I get one for you.
See,
Got it? That's your assignment, page 194.
Is that just everything on page one?
Yeah, we can't see it on the.
Okay, so it's just the stuff that we can do. Okay, got it down. Oh, yeah.
Yeah, you don't need that, Dawson. Because I wouldn't agree with that next class.
Oh, okay.
Hey, Raven, will you reach in and turn that light on for me?
Did you write it down?
Oh,